Hi everyone, welcome to the Today we'll discuss about some of the non-ferrous metals that exist and most important non-ferrous metals which are commonly used. As we saw, the ferrous alloys offers a wide varieties for different applications. And why do we need non-ferrous alloys? Yes, iron and steel, though it's a dominant material used, it has some of the drawbacks. What are the drawbacks? Iron has inherently high density that makes the material heavy, and iron is highly susceptible to corrosion. Corrosion behavior of iron is not very good. It corrodes, that leads to the loss of material, that affects to the failure. In addition, it has the electrical conductivity of iron and iron alloys is comparatively low compared to some of the non-ferrous alloys which are available. So these drawbacks which exist in the iron system or ferrous alloys can be countered by using non-ferrous alloys. There are non-ferrous systems which can be counter different problems which exist in the ferrous system as per the requirement. Thereby we choose a particular amount of non-ferrous system if we require a better electrical conductivity or a different system if we require low density. Let us see those kind of metals which we have. The most important non-ferrous metals that exist and are readily available are copper, one of the most important metal in addition to the iron. Then we have aluminum, magnesium, titanium, zinc, and some of them. These are some of the most important non-ferrous alloys. I will discuss them one by one. To begin with this, let us start with the definition of non-ferrous metals. Non-ferrous metals are those, as I told, which do not have iron as its main constituent. The examples I told: copper, aluminum, zinc, tin, and all. Okay, they are usually used because to overcome the drawbacks which are present in ferrous metals. And the advantages of non-ferrous metals is using easy to manufacture, and it has good resistance to corrosion. It is a good conductor of heat and electricity, and it has less density when compared to ferrous metals. These are all some of the advantages. Next, we'll move on to one by one. This will move on to the types of non-ferrous metals, that is copper, aluminum, zinc, tin, and all. Let's study in detail about each metal. Let's move on to the next one, that is copper. Copper is a very soft and ductile material in its pure state. This extra soft nature makes the copper to copper difficult to machine. But the soft nature has the advantage; it can be easily deformable. See, it becomes soft, malleable, and ductile. This copper is the most important metal next to iron, which is used by engineers. This is obtained from its ores, which are oxides, sulfides, and so on. And coming to the properties of copper, it has reddish color, bright luster. You have seen this copper. You can see this in this sketch here. And it is highly malleable and ductile, and it becomes brittle just below its melting point, and it can be worked in hot or cold conditions, but it cannot be welded. And then it has a good conductor. It's a good conductor of heat and electricity. And one of the advantages, it is not attacked by dry air, but moist air gives a green coating to the copper surface, and it is also not attacked by water at any temperature. It is malleable, ductile, and extremely soft, and it is highly resistant to corrosion. And the only problem with copper is the copper alloy generally cannot be strengthened by heat treatment. Because of this heat, by heating, the copper cannot be strengthened. Therefore, the copper is used for cold working, and solid solution is done to improve the strength of this copper. Hope you have understood the properties of copper. It is very simple. The next we'll move on to the applications of copper. What are the uses? Where it is going to be used? Yes, copper it is mainly used for electrical cables, household utensils, and all. In the electrical industry, the copper is used for the manufacturing of generators, motors, switchboards, communication equipment, of course wires. Inside the wires we can see the copper wires for the transmission of sound and electricity. These are all the applications in electrical industry. In the chemical industry, as you know, the copper is highly resistant to corrosion, and it is highly thermal. It is a good conductor of heat. Therefore, the copper is used for making copper dyes, utensils for food industries, milk processing, and refining industries. And all is going to be used. And alloys of copper. Some alloys of copper like brass and bronzes. Okay, these can be made with the help of using copper. With the help of copper, the alloys of copper can be made. Briefly, we can see the properties. The copper is ductile, malleable metal. It is red in color. It is a good conductor of heat and electricity. These are some of the important properties. Uses where it is used for making electrical components, plumbing, cookware, and roof coverings. The melting point is 1083 degrees Celsius. And these are all some of the uses, applications you can see in these sketches. That is about this copper. Hope you have understood the properties and applications or uses of copper. The next non-ferrous metal is aluminum. Yes, the next one is aluminums. The main thing about the aluminum alloys is it has low density. The density of aluminum is around 2.7 gram per centimeter cube. And aluminum has a very good, it is a good conductor of electricity and heat. But you can say the aluminum is a good conductor of heat and electricity. It has high electrical and thermal conductivity, and also it has low density. Okay, and then it has high corrosion resistance, and therefore aluminum alloys are very having it has a good resistance to corrosion. That is one of the property. And then it is usually silvery white metal with bluish tinge and exhibits some bright luster on a freshly broken surface. And then it is a non-magnetic substance, and this is lightest metal, and its melting point is 650 degrees Celsius. Low melting point, that is high boiling point is 2056 degrees Celsius. And I told it's a good conductor of heat and electricity. And it is a ductile material, and it can be transformed to any shape. It can be cast into any shape by any method of casting. It may be a die casting and all. As I told, it is having high resistance to corrosion. And its specific gravity is around 2.7. And it is readily dissolves in hydrochloric acid. These are all some of the properties of aluminium. Hope you have understood the properties. Next we will move on to the uses of aluminiums. Yes, you can see it briefly. You can see this. Before I go to the uses, you just watch this slide. The properties of aluminium, about its durability, light in weight, it is a non-ferrous metal, the color of the aluminium, good conductor of heat and electricity, and then it exhibits luster on freshly broken surface, bright luster. The density is less and it dissolves in hydrochloric acid with a melting point in the boiling point. The specific gravity, it is high, it has high tensile strength, it is a non-magnetic material, and it is a good, it has good corrosion resistance, it is ductile and malleable. With this slide, you can easily remember the properties of aluminium. These are all the properties of aluminium. The next one is applications of aluminium. The aluminium is used for making frames and railing of roofing. In the structural engineering, it is used for making frames and roofing materials and all, building doors, windows, gates, and all can be made of this aluminium. In the aircraft industries, as it is an alloy, it is used for making some aircraft parts, and in the railways industries it is used for the fabrication of railway wagons and other railway body products, and in the automobile industries it is used for the fabrication of bodies of trucks and buses, and in the electrical industries it is used for making the wires and all. In the chemical and food processing industries it is used for making the aluminium tanks, condensers, heat exchangers, containers, aluminium foils. And it is also used for making cooking utensils. As your daily usage, you are going to use this aluminium ಪಾತ್ರೆ use ಮಾಡೋದು. Due to this, why it is used because of this high thermal conductivity. It can be used for making cooking vessels and cooking apparatus. These are all some of the applications of aluminium. What are the advantages? What are some of the advantages of aluminium? Aluminium has high corrosion resistance to atmospheric agencies, and this advantages of aluminium is it has high corrosion resistance, and aluminium is very light in weight and hence it can be transported easily. It absorbs less radiant heat and hence it has a good reflectivity. Those are some of the advantages of aluminium. Totally, we hope you have understood the properties and applications or uses of aluminium as engineering material. Here you can see the applications of engineering material. Application of this aluminium as an engineering material used in the aircraft bodies, in the motor bodies, vehicles, and all in some of the parts of the machineries can be made of this aluminium. Hope you have understood the properties and uses of this aluminium. It is very simple. The next we will go on to the next. The next one is zinc. Coming to the properties of zinc, it is whitish in color. It is somewhat bluish white. It is somewhat bluish white in color, and it has a bright luster on its surface, and it burns with a greenish white flame when strongly heated in air. And then its density is around 7.4 gram per centimeter cube. It's more than aluminium weight ಸ್ವಲ್ಪ ಜಾಸ್ತಿ weight ಇರುತ್ತೆ zinc. Aluminium is the lightest metal, and the specific gravity of this zinc is around 6.2. The melting point of zinc is 419 degrees Celsius, and it boils at 907 degrees Celsius. The boiling point of zinc is 907 degrees Celsius. And the tensile strength is around 700 to 1400 kg per centimeter square. And it is a good conductor of heat and electricity as of other metals. And it is not affected by dry air, but in moist air, zinc surface gets covered by a dull basic zinc carbonate. And And some other one type of zinc, that is filtered zinc, is easily attacked by acids. And zinc is not affected by pure water, and it also resists corrosion, and its specific gravity is around 7.14. These are all the properties of zinc. Hope you understood the properties of zinc. It's very simple. The next one is application of zinc. Where zinc is going to be used? What are the uses? Zinc is mostly used in galvanizing other materials. See here, you can see this in the galvanizing, coating iron and steel with a protective layer of zinc. Iron and steel is coated with a zinc layer. 40% of total world production of zinc is used for galvanizing. The main advantage of production of zinc, the zinc is going to be produced mainly for the galvanizing process. The iron metal or the steel metal is galvanized with a layer of zinc. Galvanized steel is used for car bodies, street lamp post, safety barriers, suspension bridges, and so on. The another application of zinc is die casting. Die casting is nothing but, as you can see here in this sketch, that is die casting is done due to its low melting point and resistance to shock. Okay, this is used for die casting. Die casting in automotive industries and electrical industries such as speedometer frames, parts of hydraulic brakes, in some washing machines, vacuum cleaners, motor housings, and all. This die casting zinc is going to be used in this. Totally, the large quantities of zinc are used to produce the die castings. Those die castings are important in the automobile and electrical and hardware industries. That is also one of the application. The next application is zinc is also used in alloys, in making alloys such as brass, nickel, silver, and aluminum solder. Zinc is used for making brass making. The copper alloys and with zinc forms group of alloys. Brass is 20% of zinc production is consumed in manufacturing of brasses. In manufacturing of copper alloys, that is brasses and bronze, zinc is going to be utilized. That is one of the application. And then zinc oxide is widely used in the manufacture of very common products such as paints, rubber, cosmetics, soaps, batteries, and all. The another is zinc sulfide is used for making luminous paints, fluorescent lights, and X-ray screens, and so on. These are all the applications of zinc. Hope you have understood the properties and application of zinc. The application of zinc is galvanizing, die casting, the wheel application, and brass making. These are the three important applications of zinc. That is galvanizing the iron and steel, and making die casting, and the brass making. Okay, hope you have understood the properties and uses of this metal, the non-ferrous metal, that is zinc. The next one is tin. Tin it's not there in your syllabus, but still I'll just brief you about what is this tin. This tin is a very ductile and malleable metal. This also has resistance to corrosion and from the moisture. It is bright silver in color. Tin plate in steel with a tin coating. What are the uses? Means it is used for as a coating on the food cans. Tin related to the tins, small tins. It is coated over the food cans. And the melting point of this tin is 231 degrees Celsius. These are not this tin, but you don't have this syllabus. Only the three non-ferrous metals were there: the copper, aluminum, and zinc. Hope you have understood the properties and uses of copper, properties and uses of aluminum, properties and uses of zinc. The next one is difference between the ferrous metals and non-ferrous metals. In the ferrous metals, you know, iron is its main constituent. In the non-ferrous metal, iron is not the main constituent. And the second major difference is they have magnetic property and makes them prone to corrosion. Yes, ferrous metals has can be magnetic. They possess magnetic property. But the non-ferrous metals do not possess the magnetic property. And these ferrous metals prone to be corrosion. They can be easily corroded. But the non-ferrous metal have resistance, much resistance against the corrosion. That is one of the advantage of non-ferrous metal. And these ferrous metals have high tensile strength. Non-ferrous metals have low tensile strength. The examples for ferrous metals is, you can see here already big iron, steel, cast iron and all. The examples for non-ferrous metals is aluminium, zinc, copper, cobalt, tin and so on. The ferrous metals are mainly used in the magnetic attraction of iron may be disadvantages. That is, it is used where the strength is primarily focused. The magnetic property where it is not required, it is given least importance. Where the strength is given more importance, there the ferrous metals are going to be used. In this, the non-ferrous metals where it is going to be used means it is ideally used for the electronic and electrical applications. Hope you understood the difference between these ferrous and non-ferrous metals. Total, you can say the ferrous metals. In the ferrous metal, iron is its basic constituent. In the non-ferrous metal, iron is not the basic constituent. The ferrous metal possesses the magnetic property. Non-ferrous metals do not possess this magnetic property. Ferrous metals are more prone to corrosion. They have less resistance to corrosion. But the non-ferrous metals have more resistance to corrosion. They will not corrode easily, you can say. And then these ferrous metals have high tensile strength. The non-ferrous metals have less tensile strength. Ferrous metals are having a good weight. That means their density is heavy. It is heavy, you can say. The ferrous metals are heavy and its density is high. But the non-ferrous metals are lighter in weight. And the ferrous metals are used where the strength is given main advantage. And the non-ferrous metals are used for electronic and electrical applications. The examples for the ferrous metals is pig iron, steel, cast iron and so on. Then the examples for non-ferrous metals is cobalt, aluminium, zinc, tin, copper, tin, etc. These are the difference between the ferrous metals and non-ferrous metals. Hope you have understood the differences and then the properties and uses of aluminium, copper and zinc. Thank you so much.